Hi, I'm Cornelius Willis. I'm with the Cloud Platform team at Google. And today we're going to have a conversation about container technology. In fact, you might say a grown-up conversation. And we've got some leaders from the container software industry here to share perspectives with us, starting with Alex Polvi, who is the CEO of CoreOS. We also have Craig McLuckie, who leads the product management team that works on containers here at Google. And Kit Colbert, who's the CTO for the cloud native applications effort at VMware. And with that, we'll get started. We have questions for all of you. So First of all, why does anybody care about container technology? Why are we even having this conversation? Why does it matter?
Okay, maybe I'll take this one. So I think about container technologies as being important for two reasons. The first reason is what is today, and then the second part of it is where's it going in the future? And both of these are worth discussing. The first part of it today, as exemplified by Docker, is that container technologies have solved a really hard problem around the hermetic sealing and deployment of an application. So they've taken something that has historically been very fraught and difficult and occasionally fails, to becoming something that's very predictable and has a great developer experience around it. And so they've solved this hard problem in a way that's accessible to engineers, and engineers like it for that reason. The second thing I think a lot about containers is where containers are going. And if you think about it, containers really grew up as a technology in the internet giants, because it's the only practical way to accomplish internet scale computing. Now, as we look to the future, every enterprise is on the cusp of needing to act as an internet company, as IoT and mobile-enabled workforces emerge. They need access to the capabilities that have previously been the provenance of the internet giants alone. And what I see containers technologies doing is really moving the world forwards into this cloud-native computing paradigm, and letting everybody benefit from the same paradigms of computing that people like Google or Facebook or Twitter or others have had to sort of build for themselves and pioneer for themselves.
So if we think about a world before and after, right? What is container technology replacing? And what will it never replace? What are we doing now today that we're not going to do in the future when we have everything running in containers?
Yeah, I mean, one thing I wanted to add to Craig's point actually on the previous question was that I think a lot of times when we use the word container, we actually bring in a lot of other concepts with that, right? There's one thing around basically what container technologies like Docker have done, which has provided like a great packaging framework and then the Docker engine orchestration framework on the Linux host. But there's a lot of other aspects to the application and the way the application that is produced that I think really derive like the kind of end-to-end benefits that folks are looking for. So containers are absolutely enabling, and they're awesome, right? And they're great. But then there's questions like the application architecture. And so a lot of that's breaking down these more monolithic architected apps to be something you might call distributed or microservices. And as you do that, you enable your development teams to start moving more independently. You build more agility into that. Then there's things like continuous integration and continuous deployment that are a whole process around how you really optimize and automate the software development lifecycle. So I think it's really important to point out that when you say containers, a lot of times people think about this, they kind of see all these different pieces, which each have specific areas and names and technologies behind them. But then there's kind of the actual container technology that you were talking about, Craig, as well. Sure. So I think it's important to kind of distinguish that there's many different pieces here going on.
Well, I mean, we've talked about almost every part of software development lifecycle. I mean, this touches on everything.
It is, and I think, to get back to Craig's point, this notion around how every company's kind of becoming like a web-scale internet company, I think is absolutely true. I think it was Mark Andreessen, right, 4 or 5 years ago now, that was saying that software is eating the world, right, as that big op-ed in the New York Times. And his point there was that companies are by and large becoming software companies in the sense that software is how they engage with their users and is by and large how they differentiate their products, right? Doesn't matter what industry you're in, you're kind of becoming a software company. So it's one example of this, right? So this company, John Deere, they've blogged very publicly about the kind of transformation they made. So this is, again, a company that does tractors, combines, that sort of thing. And yet the value to their customers is no longer just the tractor that they build. It's actually the sensors they put on the tractor, the fact that it beams that up to the cloud. They have this big data analytics platform that runs in the cloud, and that information then goes back down to the tractor so they can then optimize and maximize the productivity of the land. And that's what they're really producing. And so think about that transition, right, as a company. And what John Deere has been very vocal about is their use of containers and continuous integration and deployment, all these other things that have come together to really differentiate them as a business in the software world. So I think that's kind of, if we ask the why, that's the why. Because if John Deere didn't do it, someone else would come out and they'd make an okay tractor
right.
and an awesome analytics platform, and they would eventually beat out John Deere, right? So I think that's the kind of competitive environment that is starting to form.
Software is a competitive weapon.
It is, absolutely. It's a huge differentiator.
Yeah. So, myths about containers. Who's got some myths that we need to bust about containers?
Definitely have some myths. There's a bunch of myths rolling around right now. One big one is that containers replace virtual machines, for instance. I think.
Yeah, that's one that we hear a lot.
Do you agree?
So here's the big picture. So container as this little bit unit, yeah, it does kind of resemble a virtual machine if you like squid at it the right way. But when we're talking about containers, we're really talking about this thing that Craig alluded to, which is this way of managing infrastructure that the hyperscale guys have done for a while now, but hasn't been done really in enterprise. And the difference there is with a virtual machine, what you do is you take a big server and you carve it up into lots of little servers and you treat them as like their own little servers. With containers, you take a set of containers and you deploy them and you manage them as one big machine. So it allows you to string a set of machines as if it was one giant thing. It's this idea of managing a data center as a computer as one. And that has a lot of benefits around letting the software do the optimization of utilization, or letting it help the operations team actually keep things up and available and so on. So if you think about it that way, a little bit bigger picture than just that container, it's completely different. Right. One other one, just call out and let you guys go after that, is around security. So containers have gotten a pretty bad rap for security, but we have to step back for a moment and think about what were you doing before containers. And what you're doing before containers is you were just running a bunch of different applications on one machine. And if any of those things got compromised in any way, the attacker now can go get the rest of the server. And it's rather trivial from there. At least with containers, you're putting up some boundaries and walls between every single individual application. Really, the only way that you could do that previously is if you launched a full server or virtual machine for one application, which it sometimes happens, but isn't the typical use case of server infrastructure. So even today, the containers have gotten a lot of criticism for security, but then you need to stop for a second and be like, wait a minute, before this, you were just letting everything kind of go to town. But
so let me add to the first one, and maybe Kit wants to talk to the second one. There's some interesting conversation about there. I think Alex is exactly right. I think the biggest mistake people make around containers today is they think about it the same way that they think about that virtual machine. And there's a couple of things that are really important that one needs to consider. The first is, with containers, you're creating something that is far more atomic and easily schedulable. So if you think about the way that people tend to run virtual machines, you'd build something in a virtual machine, it'd be vertically scalable. You could add additional resources by creating additional processes, but eventually you'd get to the boundaries of your system, and then the wheels would fall off. You would have to really kind of change your sort of way of thinking. You'd have to make this big, bold transition into a distributed system as well, and it was really hard. Right. So it was easy for people to build systems that would scale to a point. It was practically impossible for most engineers to build systems that got beyond that. And one of the things I think that we have an opportunity to do as we move towards the containers is to think about the atom of deployment as being at the process level rather than at the sort of subsystem level, and creating a very natural way to tie these things together in a useful fashion so they can be easily stood up, consumed, scaled, turned up, turned down. And by doing so, producing tremendous value for the end consumer, because you get far more efficient use of your resources, you don't have to worry about scaling events, the health of your system is managed for you, and you get far more insight into how things are behaving because you're operating this higher abstraction. I think that's an incredibly key construct as we look to the next 10 years.
Yeah, and I'll say, I think on that note, when people think of VMs, there's multiple aspects to it. I like to just decompose into two simple aspects of a VM. There's kind of the VM as the packaging mechanism, right? That you can install an OS and put an app in there, create a VM template, and then provision that thing as much as you want. But there's also the VM as the runtime vehicle. And I think that what we see is VM packaging was kind of a necessity before containers, and just with a lot of traditional applications, especially more off-the-shelf applications where you didn't control it, you didn't have in-house development able to change it, and it was kind of the way it was. And so VMs offer great flexibility there. But as we get into the container world, it makes a lot more sense, if you can, to package an application inside a container. I think our point of view, of course, is that we think we can bring a lot of the benefits of the VM runtime to containers, right, from a runtime scenario. But I think the other point I would make just on the misconceptions around containers is again this notion that when we think of containers, again, the association with that is typically like a Google-style type infrastructure. I got this awesome app which is like highly distributed and totally resilient to infrastructure failure and all these great things. And then people say, okay, well, I can take my old 20-year-old legacy monolithic app, toss that thing in a container, and boom, I'm good to go. Right? It's like the magic pixie dust, and all of a sudden this thing is highly scalable and resilient to hardware failure. And it's like, actually, no. The container is very helpful, but if your application, it's very helpful in the sense. Let me finish that thought. Very helpful in the sense of being able to reliably and quickly reinstantiate that application on any infrastructure you want. But if the application is broken, doesn't scale, falls over a lot, they're going to have a broken, not scalable application that falls over a lot that you've reinstantiated 1,000 times faster. So I think the big thing that I always talk to customers about is, and users about, is like, hey guys, you not only need to think about containers, you also need to think about application architecture, because that's the much harder thing to do. Is how do you actually re-architect the app to take advantage of this distributed paradigm?
Right. It's not a lift and shift of your old app, but suddenly your old app is magical.
Yep. And that, again, that's maybe another VM comment there, because the VM enabled that sort of lift and shift.
Right.
But with containers, you can do that, but you don't get all the benefits, right? To really realize the full benefits, you need that sort of rethink on the architecture side.
One kind of additional point to make there is I agree with you. I think there's a big sort of cognitive shift that needs to happen. But it's far less big than the cognitive shift has ever been before. If you think about the bad old days of SOA, I don't know if either of you worked on SOA technologies.
Something to do with XML, right?
Yeah. Or tried to deploy an enterprise service bus. The process of actually getting to the goodness of this distributed systems, you'd have to make these huge investments.
Right.
You'd have to retrain all your engineers around these new patterns, and you'd have to re-architect your systems to actually use specific protocols. Right. And it was a disaster because the energy curve was, like, the value proposition was there. It was possible to achieve these patterns of operating previously. But there was such a cognitive hurdle to get over that was practically impossible. Right. Mm-hmm. And so I think one of the things that we're starting to see now is, Docker's made it easy to kind of encapsulate something in a medically sealed unit. Modern sort of technologies that are actually scheduling it make it feel like it's just running in a reasonably local environment. But you can use SDN to wire things together. You can use software-defined storage to actually map volumes in, create a natural experience, but actually start benefiting from a lot of the values of this higher abstraction, which is very powerful.
So it feels like it's at the right time.
Well, I think that's a really good point. I think that's an excellent point, because I think what you're kind of getting to is this whole notion of, the infrastructure architecture and the application architecture stack is evolving as well.
Yes.
Whereas before, you had to do a lot of this stuff yourself and figure out a lot of these hard kind of distributed systems problems, implement your own Paxos or whatever it is, right? What we're seeing now is a lot of this stuff is available, many times open source. And so rather than you figuring it out, you can rely on some other component to do it. You can focus much more quickly, I think this is your point, on the business logic of whatever the specific thing is that you're building, and not have to worry about all like the 10,000 other kind of problems that go along with that. Right. But you have these libraries or frameworks that you can use out of the box.
So what needs to happen in the industry that isn't happening now for containers really to take hold? What are the hurdles we need to get over?
So here's where we're at right now with it. It's this whole new platform, okay? Right. And I like to use the analogy of a phone, okay? Right. Imagine if your iPhone or Android booted up and there were no apps on it. And the first thing you had to do as a business was to write an application to make the platform. It's this revolutionary new platform, paradigm shift and everything, but the very first thing you have to do to use it is to create your own unit of value on top of it. Right. And that's where we're at right now. We'll stay there. All the tools are there, but the teams that are using them have to do a lot of the heavy lifting to sort of feel the value of it. So I think as an industry, we have to mature a little bit in terms of having solutions put together for users that already go in there. We need to write the dialer, we need to write the camera app, we need to write the gallery app for you, and that kind of stuff. The general purpose things that every operations team needs just to make the thing useful to them is the challenges that I think we're getting through right now. But the base platform, it's getting pretty good and it's exciting.
I would agree with that. I would add one thing, which this thing is really important, is we have to create effective standards around some of the core pieces that everyone wants to build on. Mm-hmm. If you think about what containers are doing, is they're creating a natural way to express a piece of software and describe how you want to run, and then creating a framework so you can actually take that thing and run it. And we need to create a standard that lets people really innovate and advance the story around the packaging and distribution of containers, continuous integration and delivery, new and unique ways to take code and actually get it into this environment. secure operating environments for these pieces. And we need to do that in a way that fosters a whole ecosystem. And to do that, you need to actually define a clean standard. And then on the other side of it, you need to be able to consume that and run it in a broad array of technologies. I mean, each of us are vendors and have our own set of offerings that we need to consume. It'd be kind of nice if there was a standard that that people could really invest in that really decoupled the production and the consumption of technology. And that's why I think things like OCI are incredibly important. And it's incredibly important that OCI focus not just on
OCI, Open Container
Open Container Initiative, thank you. Focus on really creating a clean and sort of well-adopted standard for that separates the production and distribution of container technologies from the runtime and consumption of it.
Yeah.
But standardization on both sides of that.
Yeah, so having a standard sort of specification so that the people who are operating on the one side of the divide who actually want to build and tool around containers can work to that specification, and then people on the other side of the divide who want to take those containers and run them and operate them have a common ground to meet.
Right.
So that the tool providers aren't trying to tool for n different providers' implementations of the specification. But that it also allows each of the end providers of the specification to create unique value and differentiate and actually offer up real innovation in that space.
Yeah, and getting back to the question around adoption and the maturity in the space. So I think if you look at what happened, let's say with VMware's story in the virtualization space, that took a good, let's say, really started on the data center side probably in 2000, 2001, and just in the last couple of years have we reached kind of the point where people aren't afraid to virtualize things anymore. Before, there's always some kind of concerns, and the concerns varied in a number of different ways. A lot of times it was just a question of, can I, as an operations group, really run this thing in production with some sort of assurance that it will run, and I can take care of problems when they happen and so forth. And so I think what we've seen is tremendous excitement from developers, because developers get the value proposition of containers. They get Docker and they see how it can help them. And so now I think that the transition point is, to follow on Craig's point, that we're seeing tooling come out around this as well throughout the CI/CD space and now over onto the production side. I think that's going to be where the rubber meets the road in terms of as IT teams and operations teams start to take a look at this and say, okay, how do we actually run these things in production? How do I make sure it's secure, and how do I audit that, and how do I monitor it, and do I need to do backups, and all the sort of things that they have to think through. So I think what we're seeing is, I think this actually kind of evolved faster probably than virtualization did, just because the amount of interest that's here right now and the amount of folks that are jumping into the space. But at the same time, I think that right now it's very much, for most of the customers we talk to, they're the kind of cutting edge ones, the ones who are willing to take a bunch of this stuff that's still kind of just starting out and kind of put it together in a way that works for them. And what you'll see happening over time is more out-of-the-box solutions, things that just kind of work and are able to let these IT teams take it and run.
Right. So what's happening with the Cloud Native Computing Foundation? It seems kind of quiet lately. What's the story?
Okay, I'm glad you asked the question. We've been doing a lot of work to basically put together a framework that we think will work well for the community. We're looking to really create a foundation that operates fairly, that has a very strong technical identity and technical voice, that welcomes a broad array of technologies, but at the same time achieves a convergence that makes it useful. So we've been spending quite a lot of time in a series of conversations through the community channels to really get the details of how to make it run work. And there's actually a lot of effort and a lot of thought is going into, how do we create an effective oversight committee that isn't bound to a specific commercial interest? How do we create a group of people that are representing the end users so that that voice isn't drowned out by vendors that have a strong commercial interest? And then, how do we create a principled architecture that is, fair to everyone in the community, whether they're end users and vendors, and really sort of bring it together. So behind the scenes, we've been working really hard to get a lot of the details ironed out about how it's going to work, how things will be managed, what the governance structure is, and we're getting very close to actually being able to make a really sort of strong announcement around getting through contracting and actually starting the day-to-day operations of the foundation. So things are going very well.
So assuming we have successful standards efforts, and we're able to link the development world with the runtime world through well-expressed standards, what does a thriving tool ecosystem look like for containers?
Sure. So I like the standard shipping container analogy a lot for this, because it's very applicable. So once we have our standard on the unit, the goal is not just to have a standard, it's to have like a global economy. That's the point of this. So by having a unit that as a user you can package against and know that you have a variety of vendors that all interoperate with that, you should see a rich ecosystem of people that are competing for your business, as well as some pretty good innovations because of that. As if we have the bare minimum piece of a standard, that means as vendors we all have to duke it out and like earn your business, right? We have to make our stuff faster, more secure, more reliable, and so on. So for the end user, the standards create that. And again, using the analogy here, the goal is not the standard, it's the whole global economy that's created because there's that basic standard in place.
Yeah, I think Alex, hit on that with this. And what we talk about when we talk about this with customers, the word that I hear a lot is optionality. Right, this ability to not get locked into something, that they can make the choices based on their requirements. They can free to change those choices as they need to, and I think that's kind of the vision that we're all trying to get to. And by the way, that's also a big reason for open source. We have a lot of open source technologies, and customers wanting to leverage those things. It goes back to optionality of multiple vendors backing that open source project. So I think, when we see the container space as well, we don't want it to become this super fragmented area where, so then you have to, if that happens, you'll start making these crazy kind of chains of dependency decisions. Like, so if I select this technology, then I can do that thing well, this other thing not so well. Right. If I do this one, then that one works okay. And it's like, no, let's make it very simple. You do the default, standard packaging or whatever it is, and then you have choices. Do I want to use this sort of technology for networking, this one for storage, this one for scheduling, this one for consensus? It gives you options and allows you to leverage the best of breed without getting locked into anything down the road.
On the vendor side, it also lets you invest in the standards so you can innovate off of the standards.
So we make our solutions better rather than having 5 people reinvent the wheel 6 times.
Right. And I think that actually is a key element to driving innovation. And I would extend that to other parts of the stack as well. I think it makes sense to try to create a series of principled interfaces between subsystems so that if someone has a really killer implementation of something, they can safely invest in that and innovate in it and actually have it pulled through into a variety of other areas. And so I think really pursuing that is important. And I think one thing I'd like to say, which is kind of just stepping back a little bit, when I look to the future here, a lot of things are going to change, and people try to play their understanding of how operations works, into this new world, and it's going to change. We're going to create a radical specialization of ops. The number of people you're going to have to maintain to operate a series of systems is going to reduce, and specialized operations functions are going to emerge. And I expect each of those operations functions will have a unique set of tools, and it should be safe for providers to really focus on lighting those things up. The container abstraction level provides a remarkable amount of data you could use for things like intrusion detection if you want to drive security. It'd be wonderful if an ecosystem could emerge around that. So I think that's likely to happen. And then the other thing I think is going to happen is, one of the things we saw inside Google when we made this transition a long time ago is this incredible explosion in productivity. It turns out when you actually make this transition to not having to have your engineers spend half their life or more actually trying to maintain and operate the thing they just built, but that principled systems can run them for them, they become radically more productive, radically more code gets produced, and you need new classes of tools and new ways to actually define policy and see what's happening and track the things that are being deployed. So I think it's going to introduce a very substantive change in the way that people actually build and operate and run these technologies, and the actual set of tools, the suite of tools, is going to evolve in new and interesting ways.
So what's the pre-flight checklist, right? When we look at some point, this is going to become container technology is going to become the default packaging mechanism, the default way we develop software. What's the pre-flight checklist for how that happens? When do we know that we're there?
Well,
I have an answer to that one. I think so. It's really about the user, and when the user is able to package their application once, sign it, which means it's them saying this is my package, and then run it across a variety of vendors. They can choose Google Container Engine, they can choose the VMware products, they can choose Tectonic from CoreOS, like these different things, or any other vendor that wants to interoperate with that standard. But the user can take that unit, they can say this is mine, and then they can run it in their own, in the place of their choosing. I think that's what we've done it. We actually have interoperability and standardization and choice for users.
Yeah.
And I think it's going to take the classic sort of adoption curve, right? Where you're going to have some people on the leading edge who are willing to like roll up their sleeves and do the extra work and sort through the myriad number of options and just make it work, right? And deal with some of the issues of the changes and so forth that happen down the road. But I think we're definitely going to hit an inflection point where it is kind of ready for mass market. I think that's sort of the point that Alex was making, is that there's going to be a point at which this stuff works well enough out of the box. The early adopters have figured out a lot of the hard problems around operationalizing these things in production and some of the other issues there. And then, and we're always trying to do, the cool thing about the container space is that it really is a community. If you go to any of like the meetups or the conferences, you see a lot of people sharing their experiences. Like, here's, I'm at a company, I took this thing, we started running it, and here's all the problems I hit, and here's how to avoid those in the future. So as we collect that sort of knowledge as an industry and it's a community, it will help everyone who's new to the community even go faster, right?
Yeah, I agree with that. I think every customer is going to be different. We already have a lot of customers that are, they roll out these amazing statistics around, how it's changed the way that they take the technology to production. And they're able to go from one rollout every 2 weeks to multiple rollouts a day, that their operations are sort of going down. So for a lot of the forward-leaning people, it's been ready for quite a while, and they're already benefiting from that. At the far end of the spectrum, a lot of folks need developer training to actually become familiar with the tools. They need their favorite systems integrator to actually develop a practice around this and to actually fully inculcate it and acquire a staff that can actually support their needs. And so it's gonna trickle through technology exactly as VMs did, right? Like if you think about that VM adoption cycle, that took 8 years or however long to really become prevalent. I think it'll probably go quicker because there's to Kit's earlier point, there's a lot of interest around it. But I think every customer will make their decision based on their specific needs around completeness of tooling, willingness to engage in open source and actually participate in the evolution of the open source technology. Their vendor providing them a comprehensive suite of tools that they need. Their systems integration partners actually being there to help them through some of the transition processes. So I don't think there's a one phase answer, but it's going a lot faster than I expected, is what I would say.
So with that, I think we've had a good grown-up conversation about containers. No chairs were thrown. Nobody stalked off the set. Good.
Success.
So thank you all for joining us today, and thank you for watching. As I think you can hear, this is the coming framework for how we will write and run software. So our encouragement to you is to go out and learn about it. And there are lots of resources from all three of these vendors about container technology, so go try it out, go work with it. Thanks so much for joining us.